Masonry Design. We will perform a column calculation and select the column module. Two column types are available, rectangular and U-shape. We select U-shape in this case. Under geometry, we define the section width to 1600 mm, the column height to 8700 mm, the thickness to 300 mm, the flange length to 200 mm, and the section height to 500 mm. Here are some masonry details. Shift height, brick length and joint thickness can be defined. We will choose to keep the default values appropriate for blocks. As support case, three options are available. We select type 2, meaning fixed at bottom and hinged at top. We continue with material. Three tabs are available: General, Brick Block and Reinforcement. Under General, the limit state is defined as an ordinary ultimate limit state case or an accidental one. Further on, the exposure class and the performance class is defined. In this case, we choose ultimate limit state, MX2, moderate aggressive environment and performance class 2. We continue with the tab Brick Block, where a number of different brick and block types can be selected, together with associated strength class. We will choose concrete whole blocks, strength class 5. The masonry manner is FJM, all joints filled, and the group is 1. For the mortar, we use design mortar category 1 and mortar class 1. In this window, characteristics capacities, the value gamma m with regard to the given input and associated design values are shown. Assuming that the column does not need reinforcement, we leave out the option reinforcement and reinforcement details and go to support eccentricity. In this window, the way the above situated slab affects the column at top and the eccentricity at bottom are specified. There are 6 options for concrete slabs and 2 options for timber slabs. We select type B2, end support top slab, steered support, with a measurement A to 200 millimeters. The eccentricity at steered support is 0. No consideration to arc action. Finally, load should be defined. We want to consider the dead load of the column, in this case 73 kN, and define a vertical load 315 kN. The horizontal load is 1.5 kN per meter, where a positive value means pressure on the column. A negative value corresponds then to suction, which is more unfavorable as it will add to the support eccentricity at the middle of the column. We perform a calculation and select result vertical capacity unreinforced masonry. The result shows that buckling will be decisive and the column capacity is not sufficient with regard to buckling check at a section along the column. The load is 351 and the capacity is only 260 kN. Some action has to be taken. We try to increase the column capacity by choosing a larger strength class. Under material, we select the strength class to 10 and make a new calculation. In this case, the capacity is sufficient and the column can withstand the loads.